Hello everyone, my name is Rutogo Goroni and I'm a member of the Uganda Astronomical Society. So basically my aim of making this video is that I want to share with you some knowledge about astronomy and basically time and other fields of physics, for example dimension, basing on my formulated theory, of which I think that it has a crucial role in both the fields of astronomy and time. So I try to reconcile these fundamental components of time, grouping time itself into the fundamental components that I myself formulated. So I use all that I formulated to explain the mysterious phenomena discovered by some big scientists, for example Einstein's time dilation. So I use my fundamental components of time to explain time dilation and how time dilation comes in. So that is what basically my theory is all about. And I use also hypercubes, for example the tesseract. This is my constructed piece of it. So I can use this to add something into my theory. So of course, as I have told you about my theory, trying to explain things like Einstein's time dilation using my formulated fundamental components of time. So I would like to share some math behind it, but before we dwell into that exact maths, I would like to share the derivation of Einstein's time dilation equation, because it is the core pillar of what my theory is all about, since Einstein himself made greater contribution on our understanding of time. So I think we can start the derivation of Einstein's time dilation equation. So it is basically around the idea. So I try using light clocks to get into the formula that we all want. So a light clock basically has a simple way of operation. So a light clock has two mirrors. It also measures time like the way other clocks do, but just because it doesn't use arms like other clocks do. So it measures time in a different way, but its operation is very simple. So it always sends a light beam from one mirror to the other mirror. Suppose this is my mirror M1 and this is my mirror M2. So a light beam is sent from mirror M1, it hits mirror M2, then it comes back to mirror M1. So it is always calibrated to a certain frequency to measure a certain amount of time. So for example, if I give this light clock to someone on a spaceship moving at a speed v, for someone on a spaceship will see things the way they are in the normal way. His or her light clock won't change, so he will perceive the measure of time as it is. It is like sitting in a car or a bus and you're moving. Basically, what you see in a bus is always normal than someone outside seeing you move in that vehicle or car. So if this is my light clock and it is heard by someone on a spaceship moving with speed v, so I can call this distance from one mirror to the other L. So I want to calculate the time of this event, the event of the light beam coming from one mirror being reflected onto another mirror, then coming back to the original mirror. So I can call the time for that event time t1. But I can form a simple equation for calculating the time of this whole event. And of course, as you know, time is equal to distance out of speed. But now here our distance is 2L, since the light beam moves from mirror M1 to mirror M2, which is a distance L, and again from mirror M2 to mirror M1, which is another L. So our distance is 2L, but our speed is the speed of light, which is c. So basically this can be my equation 1. So I can rearrange this equation into something else. When I multiply my speed of light to the left hand side of the equation, I get T1 C1 is equal to 2L, and then if I square both sides, I get T1 squared C squared is equal to 4L squared. So this can be my equation 2. So this is how someone on a spaceship perceives that nature, that measure of time. This is the time measured by someone on the spaceship. So let's see how someone who is stationary and watching someone moving in a spaceship at speed v will measure that same exact event. For someone stationary, what he or she will see is something like this. Suppose our spaceship is moving in this direction, in the right hand direction with velocity v, and I send a light beam from my mirror M1 to mirror M2. So my light beam will follow this path. It will come from mirror M1 to mirror M2, then reflected from mirror M2 again to mirror M1. So this is basically as seen by someone who is stationary. So this is the path of the light beam. I'm here stationary and looking at someone in a spaceship having a light clock moving. So this is what I see. You can try doing this simple experiment. You can try doing it here, especially in the dark. You get something, your light clock, and then you put it on something moving in darkness. So you'll see such a pattern. So you can try doing it at your own to prove this. So I can call this distance from mirror M1 to M2 x, and this distance from again mirror M2 to M1 is the same distance, which is x also. But remember, as we have seen, the perpendicular distance between mirror M1 to mirror M2 is L. The same thing that happened for our case 1. Let's call this case 1. So for our case 2, it's the same distance, the perpendicular distance from mirror M1 to mirror M2. So if we call that distance L, and then I can also try getting the distance between the positions of the first position of M1 and the second position of M2. I can get it using the velocity of the spaceship. And if I try to calculate the time of this event in case 2, I can call that time T2, even when it is the same event, because it is the same light beam moving from mirror M1 being reflected at mirror M2 and again to mirror M1. So it is the same event, but I want to show you that it is different time that is measured for the same event due to different velocities, and that is what Einstein basically showed. So I can call my time T2. So if that is time T2 to measure the distance between the first position of M1 and the second position of M2, I'll get my time T2 times the velocity of the ship. So basically from here up to here is T2 times V, because distance is time times velocity. So this is my distance. So meaning halfway, if I consider this right angle triangle, halfway I will just divide by 2. So my distance from here up to here is T2 V out of 2. The same thing that happens here. So I can try extracting one right angle triangle from here, and using Pythagoras theorem I can say that my x, which is the hypotenuse squared, is equal to my base squared, which is T2 V out of 2, the whole thing squared, plus my height, which is L squared. So, and I can simplify this equation to become my x. So I can make x the subject, and I simplify the equation to become my x is equal to the square root of T2 squared V squared out of 4 plus L squared. So this is the same equation. So I can name this equation equation 3. But from there, we can also calculate the time for this event using the distances traveled by this light beam and the speed of light. So from my formula, that time is equal to distance out of speed, but the distance covered by this light beam is this x and this other x, so it is basically 2x. So my distance is 2x out of the speed of light, which is c. But I don't want x in my equation, so I can call this equation 4. But since I don't want x in my equation, so I can just substitute this whole value of x into this equation 4. So my equation 4 becomes T2 is equal to 2 into the square root 2 out of c into the square root of T2 squared V squared out of 4 plus L squared. So this is my new equation, but I can decide to remove this square root sign by squaring both sides. So when I square this side, I get T2 squared c squared is equal to 4. Then of course, if I take a square of the square root, those two signs cancel, so I remain with my 4 into T2 squared V squared out of 4 plus L squared. So we have reached at this step, and this is basically of simplifying this whole equation. So if I multiply my 4 into this bracket, I get something like T2 squared C squared is equal to T2 squared V squared. Yes, this 4 cancels with this denominator of 4 again. And I multiply 4 with this L squared, so I get 4L squared. But we have already seen from our first equations that 4L squared is equal to T1 squared C squared. But 4L squared is equal to T1 squared C squared. So if I substitute this whole value of 4L squared into our equation, I get T2 squared C squared is equal to T2 squared V squared plus T1 squared C squared. So basically, as you can see, we have got an equation that includes the two times, but even when they have the same event, we have the equation that relates T1 and T2. So I can continue and simplify this equation. If I bring this term that contains T2 squared this side, I get T2 squared C squared minus T2 squared V squared is equal to T squared 1 C squared. So I can factorize out T2 squared, and I remain with T2 squared into C squared minus V squared is equal to T squared 1 square T1 squared C squared. So I will try making T2 the subject, so meaning I divide this value in the brackets throughout the whole equation, so I remain with T2 squared is equal to T1 squared C squared out of C squared minus V squared. So to make my T2 the subject, I will take the square root to remove this squared sign, so I remain with T2 is equal to the square root of this whole right hand part of the equation. So I take the square root, which is T1 squared C squared out of C squared minus V squared. So I can simplify this equation further with my T2 is equal to, if I take the square root of T1 squared, I remain with T1 self, so I can decide not to take the square root of C squared, I remain with the square root of C squared as it is with the square root of the denominator of the equation. So I can rewrite my equation in another way, which is T2 is equal to T1 into 1 out of, so if I get 1 out of this whole equation, the whole thing changes. The denominator goes on top and the numerator goes down. So this is from the principles of math. So this is the same as square root of C squared minus V squared out of square root of C squared. So this is my equation. I can simplify this further, get T2 is equal to T1 out of the square root of C squared minus V squared out of C squared. So this is the same thing. So my T2 is equal to, if I simplify this value in the denominator, I get T1 out of the square root of 1 minus V squared out of C squared. So this is our required equation, and this is what Einstein showed. From this equation, we can call this equation 5. As you can see, even when they are the same events, it is different. We measure different time. And here, from if you analyze this equation very well, of course, the speed of the spacecraft will always be lower than the speed of light. So meaning, this part of the equation, we shall always have a decimal here. And when you get 1 minus a decimal, you will always get a decimal. And when you take the square root of a decimal, that is also a decimal. And when you get this value of T1 and you divide it by a decimal, of course dividing by a decimal, dividing a whole number by a decimal, you always get a bigger value. So meaning that our time T2 as measured by a stationary observer will always be greater than the time T1 as measured by a person traveling at a certain speed. So this shows that time dilation truly occurs. Time dilation truly occurs when someone moves at a certain velocity. He or she experiences a different time compared to someone who stays stationary. So this is the time dilation equation. And now my theory tries to explain how this comes about with my formulated fundamental components of time. That is what my theory tries to explain, and it all begins with, so I will take you into a little bit of dimensions. So it all begins with a tesseract. So a tesseract basically is a hypercube. So I will try drawing one on paper. So a tesseract is a hypercube with 4 dimensions. The same way a cube has 3 dimensions, for a tesseract it has 4 dimensions. So my tesseract, as you can see, there is one here that I try to construct. I don't know, the visualization may be difficult, but there is one here that I try to construct, and I feel like it fits all the hypothetical properties of a tesseract. So I can try drawing one on paper. So I use these hypercubes, for example a tesseract, and I mostly use their dimensions too, and I formulate some equations, some work about it, and I think that if at all good experimental testing is attracted, this could lead to a big and a greater milestone in science, especially in the field of understanding time. So I even have some mathematics. For those who are interested in it, I will be sharing it. So as I have told you, a tesseract is a hypercube, meaning that it has more than of the usual dimensions that we are used to. For those ones who are not concordant with dimensions, so if they tell you, for example, a zero dimension is just a single dot. So for one dimension, I just draw a line from one dot to the other. This is my one dimension. It is just a line. For two dimensions, I draw another line. So for two dimensions, it is like a square. A square has two dimensions, one dimension of length and the other dimension of width. So for a cube has three dimensions, as you can see. But to construct my cube, I can just get my two squares and connect the two squares through the vertices. So my cube will look like this. So I connect the vertices of the squares using the one dimension lines to create three dimensions. And when it has now three dimensions, it becomes a cube. So this is basically how I have formed my cube. But using one dimension lines, I have formed something of three dimensions. So using the same principles, I can form something of four dimensions. For example, if I have my cube, my one cube here, oh no, you will excuse me for my drawings, but if I have my one cube there, I can form something of four dimensions by drawing another cube, let's around here, and connecting them the way you connected two squares using one dimension lines. So if this is my other cube, can try connecting them using one dimension lines. So I connect the farthest points to the nearest points of these two cubes. So if this is my near point here, I just try bringing it to the farthest point here. But you connect the top part to the top part. So the same thing, I do it here, and I do it here also. So I do it to this lower part also. So though not visible very well, but I think you can get a visualization of what a tesseract might look like. So this is my drone tesseract here. So but I have something that I drew with some greater accuracy using rulers, so you can try visualizing some like this. So this is a tesseract also, but let's go back to this side. So a tesseract is basically this thing, and so a tesseract has some properties one of the properties that it has 8 cubes in it. When you look very closely, after drawing a tesseract, when you look very closely, you will always notice 8 cubes. For starters, it may be troubling, a little bit troubling, but as time goes on, you will be able to see all those cubes in it. And it has 12 outside faces, so I think those ones might be easy to count. But what is all that a tesseract has to do with all the theory that I was talking about? First of all, Einstein himself proposed that time is the fourth dimension. So if I have a way of linking a fourth dimension with these other 3 dimensions, so I think I will always have a correct guess of what time may look like, what time may seem like, what time is it. Yes, I understand some people disagree with that idea of time being the fourth dimension, but I strongly agree with it because of what comes out when you treat time as the fourth dimension. So if this is our tesseract, so I'll try getting this physical one to demonstrate what I am trying to mean. So if this is our tesseract, if I consider these 2 cubes, it may be difficult to visualize, but hope that you try to visualize this cube with this face. It has this top face, then it has this side face, and this bottom face here. There is this cube here. Hope you can see it. And there is another cube here. It is a little bit lower than this first cube, but it has this top face, this side face here, this bottom face, and this side face here. So, but I can connect these 2 cubes using one-dimension lines. Suppose these are my one-dimension lines. So I've used them to connect these 2 cubes. So suppose one of these cubes is one world, a 3-dimensional world. So we are connected from one 3-dimensional world to another 3-dimensional world by a dimension of time, which is the 4th dimension. So using this hypercube, you can see that Einstein made the right guess about time being the 4th dimension. And someone may ask, how are these hypercubes significant in our daily life? But I can use a cube to visualize what a 3-dimensional world is by just putting it on paper and drawing my cube there. So with that same principle, I can use a hypercube, for example, a tesseract, to do the same thing. But now here it includes a 4th dimension, which is time. So as you can see, as we have said, time connects one 3-dimensional world to the other. One 3-dimensional world to the other. So from this face, when you follow the plane of time, you always fall onto the same other face, the same top face, but of a different 3-dimensional world. So hope this makes sense. Even when you take this bottom face, this side, and you follow the time plane, you always fall into another bottom face, but of a different 3-dimensional world. So I can treat that as my time. That time is the one which links you from one 3-dimensional world to another 3-dimensional world. So as time moves on, you're moving through 3-dimensional worlds. So if this is my time, I can try reconciling this whole thing with some equation, some mathematics equation. So basically, I will first take you back to Einstein's time dilation equation. From this equation, we see that when your speed when you accelerate and you reach to the speed of light, this value here will be 1, and 1 minus 1 is 0. So meaning this denominator of the equation will be 0. And when you divide something by 0 in mathematics, that is undefined. That is basically, it's like infinity. So that is undefined. So meaning at time speed, it is from this idea they conclude that at light speed time stops. At light speed time stops, time ceases to exist. For example, if something emits a photon doesn't experience any time. That same instant it was emitted is the same instant it is reaching you. So it hasn't experienced any time. So if you are moving at that photon, even when for someone who is stationary, you took like for a whole year to receive that light, for you who is on that photon, the same instant you moved from your one location is the same instant that you arrive to a different location. So I will try reconciling that with our hypercube or the tesseract. So if this is our time, so how can we relate that issue of light speed with our geometry or the dimensions of this tesseract? So in my theory, at light speed, the time ceases to exist, and at light speed, I propose that at light speed something moving at very high speed warps the geometry of space-time, and so in that warping the structure of this tesseract is distorted. So the way time is connected from one dimensional world to the other dimensional world is altered. So for example, the more the speed increases, the more this figure or the geometry of this tesseract is distorted. So at light speed we don't need time to move from one three-dimensional world to the other. So you're just there. The future is just incorporated into the present at light speed. So meaning at light speed we shall not have this dimension of time. So at light speed this ceases to exist. So it is like aligning this future of mine. If we consider this other three-dimensional world to be the future, it's like aligning it with this present of mine. So this dimension of time ceases to exist. That is at light speed. So the more the speed increases, the more the structure of the tesseract is distorted, or the more the space-time is distorted. The structure of space-time is distorted. So we can use that we can visualize that by using the tesseract that we are talking about.